Hello everyone, welcome to another video, another celestial tour. They're pretty interesting space objects that don't really look like space objects we usually know about. And in this video, I'll be talking about those, from interesting types of exoplanets, exomoons, to the unique types of neutron stars. Please keep in mind that some are hypothetical. So without further ado, let's begin. Other than Mercury and Venus, all the planets of the solar system have at least one moon, with Saturn and Jupiter having an intense amount of moons. Dwarf planets like Pluto have moons too. Interestingly enough, even asteroids have moons. But can moons have moons? These are called submoons. It is possible for them to be found on the orbit of the large moons of a planet, since the moon and the submoon with the same mass would have destabilized orbits. They're not found in our solar system, although there are large moons like our moon, Castillo, Ganymede, Titan, and others. So we would have to track exomoons to find them. One potential candidate for hosting submoons is the exomoon of the Jupiter-sized exoplanet Kepler 1625b. The exomoon is Neptune-sized. It is large enough and at the same time far enough from its planet. So that's why submoons orbiting the exomoon of Kepler 1625b could be possible. Speaking of exomoons, we have tidally detached exomoons, or orphaned exomoons, and some people call them Ploonets too. Orphaned exomoons are basically exoplanets that were once a moon of another exoplanet, but then ejected from their orbits because of tidal forces during a process called planetary migration. As of this year, no orphaned exomoons were discovered, but they can possibly be detected by using photometric methods. A video will come up about this too. As you know, Tabby star is a star known for its mysterious and random brightenings and dimmings, and scientists don't know the reason. However, it might be because of a disintegrating exomoon thrown off to its star from an exoplanet. A more detailed video will come up about Tabby star. It's a pretty interesting star, so stay tuned. Earth revolves around the Sun, and so are the other 7 planets of our solar system. Well, what if there are exoplanets that revolve around a black hole? These planets are usually called Blanets, with a B. In a scenario like this, Blanets are formed from the dust particles from protoplanetary disks around young stars that surround a supermassive black hole. As a cloud of gas and dust orbits around the black hole, dust particles collide and later on stick to each other, forming larger chunks, the so-called Blanets. These planets would of course have to be light years away from the black hole, because if they're close, the black hole's immense gravity would devour the planets. Therefore, it would take 1,000,000 years for a planet to make one full orbit around the black hole. In the movie Interstellar, there was a planet named Edmonds, orbiting the black hole Gargantua. Cool, right? Now, there are planets that don't orbit anything at all, and these planets genuinely make me terrified, personally. Like, think about a planet floating in space. Everything's cold and dark. These free-floating planets are usually called rogue planets, and there are some rogue planets that exist in our universe. There are possibly 70 to 170 discovered rogue planets drifting in space, but trillions that we don't know. Astronomers believe that the rogue planets became what they are because of a gas cloud that's too small for a star to be formed, or being kicked out of their planetary system. Astronomers usually discover an exoplanet by the help of the effects the exoplanet has on its host star. But since rogue planets are drifting in darkness, it's very hard to find them, even with the process called microlensing, finding an object based on the spike of its background light source. If you remember, I talked about the Nancy Grace Rowan Space Telescope. It is planned that this telescope will possibly discover 400 rogue planets in our Milky Way galaxy with its sharp infrared vision that can detect dark objects. Now, the important question is, would these objects hit Earth? Well, thankfully, there are no rogue planets near our solar system. The closest rogue planet is light years away from us, so no need to panic. But these objects sure are terrifying. Not to be mixed with supernovas, a kilonova is a burst of light coming from the collision of 2 neutron stars in a binary system. These explosions create heavy elements such as gold, platinum, and uranium. So that's why understanding kilonovas would be important. The result of a kilonova is a merged neutron star that becomes so massive that it collapses into a black hole. The first kilonova was discovered in 2017, located about 140 million light years away from us, and I even included the sound of it in my video called Sounds of Space. Let's listen to it again. Interesting, right? Speaking of neutron stars collapsing into black holes, that's actually what Blitzars exactly are. Blitzars are neutron stars that are so massive that they collapse into a black hole. In other words, they're too massive to be a neutron star. A magnetar is a neutron star that has an extremely powerful magnetic field. A normal neutron star still has a very strong magnetic field, a million times stronger than the Earth's magnetic field. However, a magnetar is a special type of neutron star that has a magnetic field quadrillion times Earth's, being the object with the strongest magnetic field in our universe. We talked about neutron stars, but now the thing we're going to look at is very interesting. I used to have a video about a star with a black hole in its core giving power to the star, called quasi-stars. I would have included that too in this video, but since I already have a video about it, you can just watch that video to learn more about quasi-stars. Now imagine a quasi-star, but instead of a black hole, it has a neutron star in its core. Theorized by the scientists Kip Thorne and Anna Zytkow, this hypothetical star is called the Thorne-Zytkow Object, with an acronym TZO. Theorized in 1977, these hybrid stars are formed when a red supergiant swallows a neutron star. When a red supergiant is close to a neutron star, it's possible that the two stars can merge, representing a cosmic parasite. Unlike normal stars that are powered by nuclear fusion, two hydrogen atoms being fused into one helium atom, TZOs are powered by a neutron star that prevents the gravitational collapse of the supergiant layers. And that's why these objects tend to have a longer lifespan than normal red supergiants. So some objects are hypothetical, some are officially discovered, but they're still very interesting space objects to think about. A part 2 might possibly come in the future, since there are tons of other space objects that are pretty weird yet beautiful at the same time. Thank you for watching, and as always, stay astronomical.